Today, we are discussing a topic, India's first hydrogen train. Now, let me ask you a question. A conventional diesel train burns fuel and releases carbon dioxide, nitrogen oxides, and particulate matter into the atmosphere. An electric train uses electricity from overhead lines. But what if I told you there is a train that emits only water? That is the hydrogen train. So, what is a hydrogen train? A hydrogen train is a train powered by a hydrogen fuel cell instead of diesel. The fuel cell combines hydrogen gas with oxygen from the air. This chemical reaction produces electricity, heat, and water vapor. The electricity powers the train's motors while the only exhaust is water. So remember this: input equals hydrogen plus oxygen, output equals electricity plus water. No carbon dioxide, no smoke, no diesel pollution. So how does it work? Imagine a mini power plant moving along with the train. Step 1. Hydrogen gas is stored in high-pressure tanks on the train. Step 2. Hydrogen gas enters the fuel cell. Step 3. Oxygen from the atmosphere enters the fuel cell. Step 4. An electrochemical reaction takes place. Step 5. Electricity is generated. Step 6. The electric motors drive electric motors connected to the wheels. Thus, a hydrogen train is actually an electric train carrying its own power plant on board. This is a favorite. Why is India interested in hydrogen trains? India operates one of the world's largest railway networks. Although electrification is progressing rapidly, some routes still depend on diesel locomotives. Diesel creates three major problems. 1. Air pollution. 2. Carbon emissions. 3. Dependence on imported crude oil. Hydrogen trains can address all three problems. Therefore, hydrogen trains support energy security, green mobility, decarbonization of transport, and reduction in fossil fuel imports. Why is hydrogen called the fuel of the future? Hydrogen has three important advantages. 1. Zero tailpipe emission. Only water vapor is released. 2. High energy density. Hydrogen contains more energy per kilogram than diesel or batteries. 3. Fast refueling. Hydrogen trains can be refueled much faster than charging large batteries. Then, why are hydrogen trains not everywhere? Excellent question. Hydrogen technology faces 4 challenges. 1. High cost. Producing green hydrogen is still expensive. 2. Storage difficulty. Hydrogen is the lightest element and requires special high-pressure tanks. 3. Infrastructure requirement. Dedicated hydrogen production and refueling stations are needed. 4. Safety concerns. Hydrogen is highly flammable and requires advanced safety systems. Therefore, hydrogen technology is promising but not yet cheap. Green hydrogen versus gray hydrogen. This distinction is extremely important. Gray hydrogen, produced using natural gas, produces carbon emissions. Blue hydrogen, produced from natural gas with carbon capture technology. Green hydrogen, produced by electrolysis of water using renewable energy, such as solar or wind power. For climate goals, India is focusing mainly on green hydrogen. Connection with government schemes. Hydrogen trains are linked with several government initiatives, like National Green Hydrogen Mission, National Hydrogen Energy Mission, Net Zero by 2070 target, Make in India, and Atmanirbhar Bharat. So the conclusion is, the hydrogen train is not merely a new train. It represents a shift from a fossil fuel economy to a clean energy economy. Just as steam engines defined the 19th century and electric trains defined the 20th century, hydrogen-powered mobility may become one of the defining technologies of the 21st century. And remember this one line: hydrogen trains are essentially electric trains carrying their own power plant on board.